All right, showtime. Hello, everyone. My name is Ryan Klein, and today I am here to present on a program I am learning how to use called LaTeX, and how this program has many applications for STEM majors. Before I get to that, if you want to know briefly about me, I am a first-year student here at Weatherford College. I am a part of the honors program, and one of those opportunities that comes with the honors program is being able to present at this conference, which I am doing so thanks to my teacher, Mr. Lim. This program that I am learning, LaTeX, has a very important purpose to me, especially as my major is in mechanical engineering, which I will be getting once I transfer to either Tarleton State University or the University of Texas at Arlington. But what is LaTeX specifically? Well, it is a document writing application. And if you can't tell already, based on the weird spelling and the way I pronounce it, it's not exactly pronounced as LaTeX. It is pronounced as LaTeX. You use it for writing documents of all sorts, and it has a very special prioritization for those who might be in doing research or in the STEM field. It's very much different from Microsoft Word in a way, because unlike Microsoft Word, how you write papers is through coding, which is very much different from how one would originally do it on other common applications like Microsoft Word, Google Docs, or maybe LibreOffice. The coding involved, to give a bit of an example for starters, you don't exactly code with a /, you code with a \, because with a /, you would usually use that for fractions or for dates. To be a little different, LaTeX uses a \, for its commands, and for some commands, you would type stuff inside the brackets. So to give you an example here, what I have on the right here is a sample of code from a paper that I'm writing, which is polar equations and graphs. Example this, so line 13 here, this line of text is what writes the title. It starts with the command or the title, and inside the brackets, you type whatever the title is, which in this case is polar equations and graphs. However, if you want to make the title stick out a little bit more, in this case was use another command inside that command. In this case, text df, which is make the text a bold font in order to make it big and stand out more. There's also other commands too, such as this one here, which after writing the title here, it makes the title and inputs it into the document. There's also many other commands here too, which I will be getting into in detail next. Starting from the top here. These here are packages. Packages here are a big thing if you're writing in LaTeX, because in a way, they are like toolboxes. These toolboxes add many kinds of details to a paper. So for example, some may add fonts for colors. In my case, one of these packages adds fonts. So for this line 5 here, this is the command to use a package called add fonts. This is a font that is commonly used in math-related papers. And it's one that is formally used, and it formats the paper so that the font used is that specific font. And it does it for pretty much the whole paper. Another thing that packages can do is that they might change the formatting or add some symbols they might need or want to use. So if you're writing a math paper like me, one package that you might need is AMSmath, which is this one here on line 3. AMSmath, if you're ever writing a paper on math-related topics or physics, you need a lot of math-related symbols. So for example, if you're writing a paper on polar coordinates like me, you want a way to add the theta symbol for where you're going to put the degree sign in. And using AMSmath package, it does that for you, as it's able to let you input a math symbol in there. And of course, for formatting, there is the parskip package here. This can allow you to format your paragraphs in certain ways. So what if you want to add an indentation to the start of your paragraphs? That is one of the things that the parskip package can do. And there are other packages that do this formatting too, such as full page. It allows you to have your paper formatted in a way so that you can have the document take out the whole page whenever you're putting in text and whatnot. These are but one of the many, many packages out there that are able to use on LaTeX. There are hundreds, perhaps thousands. So there are lots of packages you can apply to do many, many kinds of things with your paper. But to go a little bit deeper into the math-related section, what if you want to type some equations? Now, you don't have to worry about what these sort of math equations do. That's just there for an example. Now, one of the very important things you want to do is to enclose your equations in dollar signs. The reason for this is that whenever you enclose equations in dollar signs, it tells the program that this is an equation and needs to be formatted properly. So, for example, over here on the bottom, you can see what the equation would look like with and without the dollar signs. The bottom one here is the equation without the dollar sign. It looks okay, but you might notice that the x looks like a regular x that you might see in a regular sentence or in a regular line of text, and it doesn't exactly look like the type of equation that you would regularly see in other math papers. But the other one up here with the dollar sign, closing it, that looks much more nicer, much more formal. As you can see, this x looks nice and fancy, as all variable x's and all other letters should be. And of course, there is a nice generous amount of spacing between each character. And of course, whenever you're applying these symbols and whatnot, you want to make sure that you use a backslash for these symbols. Otherwise, you're going to get something awkward looking. You're going to get this instead, and it's going to say theta instead of showing the actual symbol, and that can be quite awkward. Of course, if you put it without the dollar signs, you would instead get something like this, and you don't want that. You want it to be nice and spaced out, so you get something more like this. Of course, want to make sure to type anything in brackets you might need. So if you're typing in a square root, you would type the square root command, which would be \sqrt, and it would give you brackets. You would type it in, and that's where you type in the equation. Math symbols. As I said, you would type these in with a backslash and put that in your equation. Now, sometimes these symbols might require a package. So the math, for example, that would allow me to have any math-related symbols. And I'm sure for other topics, there are other packages you need to also apply those symbols as well. However, despite that, it is much easier than Microsoft Word. And if you know how it works, what you would do is you would have to insert an equation, then type that equation in there. And then you would have to look through their huge array of symbols that Microsoft Word has, and that can be quite tedious and take a long time. And that is not good, especially if time is of the essence. So having the ability to write math symbols with just a simple command is one that is convenient and saves quite a bit of time. Now, what about fractions? Something that's much simpler and many of us will understand. For typing fractions, you might usually type it like this, 3/4. It's simple enough, but it's not the sort of thing that you would want to type for a math-related paper, as it might look like a date or a time, and you don't want that sort of confusion. If you type it like you would here on Microsoft Word, it would not look the best. you type it fraction as you would in Microsoft Word, it might look a bit like this. With LaTeX, you would type it a little bit differently. The command you would use is \frac. This would get you two different little brackets that you type each numbers into. So for the top of the fraction, you would type it in the first bracket, and the bottom, in the second bracket, that's where you type the numbers and letters from the bottom. However, there is a problem with it. This is what normal text would look like in LaTeX, and here is a regular fraction written with the frac command. As you can see, it's a little bit small. It's a little bit hard to read, and that's not good for a paper. So what would you do instead? In that case, you would use the dfrac command. Unlike the regular fraction command, this one makes the fraction much bigger and much easier to read and much more distinct from your text. You can see, here's another example of text like text, and here is fraction with the dfrac command. As you can see, it's much bigger, it's much easier to read, and much nicer. Of course, we'll write it within the dollar signs too, so that it looks nicer. And it's like a regular math equation. But what if you don't want to do anything math related? What if you want to input some pictures? In that case, you might need a package for that. As packages will allow you to do a lot of stuff, and some of those stuff allows you to put in images. For example, one package you could use is graphics with an X to make it sound fancy. With how you might access LaTeX, sometimes through cloud-based services, for example, you might need to have the image be with the document file. And whenever you do that, you need to also make sure that it is spelled correctly. So for example, here is an image of a tile.png from one of my math teacher's tests. As you can see, looks nice, very nice. And if you want to put it in, you need to make sure you have some parameters. On the bottom right here, you can see how that might look like in code. You would do / include graphics and put in the width of it, whether it's in centimeters, millimeters, inches, feet, miles, whatever. And this automatically formats that image to a certain size that you want. That way, you don't have to spend a bunch of time messing around with the size of it and making sure that your paragraphs don't get messed up. However, one thing you really need to make sure of whenever you add a picture in is to spell it right in your code. If you don't spell it right, you're going to get something like this. It's going to show just the misspelled text that you put in, and it's going to be looking a little embarrassing. Because if you don't fix this, it might give some readers a bit of a negative opinion on this. Because what might they think? Maybe a typo, maybe they typed a little too fast, maybe they had a bit of a fat fingers, you don't know. But you want to make sure that you fix something like this and make sure you don't mess it up, or at least catch that mistake before you finish your paper. Minor misspellings can lead to major issues. But let's look at something else, the percentage signs. If you notice at the top here, from whenever I had this example from before, you might notice that there is a percentage sign next to it, and the text has a different color. This here is how the percentage sign works. It's like leaving comments in code. Whenever you put the percentage sign before the line of text, it allows it to just simply be left as a comment. It doesn't do much. It's just a comment that you can leave so that whenever someone maybe is looking at your code, you can have it say, oh, this is what these lines of code do. Maybe you can leave comments on maybe things you thought of whenever you were writing the code. Or in another case, you can actually use it to test what a paper might look like with or without a certain line of code. So for example, maybe I want to see what a paper would look like without a certain file or document also added in too. If I put a percentage sign before it, it's going to make that code invisible to the program. And whenever it renders in that document, it's not going to load that in. And I can see what it looks like without it. And whenever I'm done, I can simply remove that percentage sign and reload the paper again, and it'll be back. It's quite convenient as you don't have to completely delete that line of code. You can simply just put that percentage sign in to test with and without it. It's quite convenient, and there's quite some useful applications involved with that. These are but some of the many commands that are out there. One example might be, how would you use section of paper? So with papers, one of the ways you can do it is with these simple commands. So with Microsoft Word, if you want to have section in your paper, you have to put in a line of text, isolate it, and then you would have to make it a certain font, a size, maybe make it bold, maybe add some colors to it. That can take too long. It can take quite a while. It can get inconvenient. So instead, with LaTeX, all you need to do is use a command, such as maybe a chapter or a section, and then you type whatever name you want for that chapter or section inside those brackets. And then whenever the paper is rendered in, you're going to see that text all by itself with that title in there, nice and big at that size, and it's convenient. Of course, if you want to have smaller sections, you can focus on other parts of a paper without having to make it its own thing. You can also have subsections, or maybe if you want to get more detailed, subsections. And of course, if you want to go deeper than that, there's paragraphs. Then more than that, subparagraphs. You can do a lot of organizing with it for very little work, takes very little effort, quite convenient. Another thing is if you're doing math related stuff, there's also matrices and tables. Of course, from Overleaf, which is one of the applications I am using to access LaTeX, they have a lot of help in finding commands, and one of them is how to do a matrix. So for example, if you just want a regular matrix with just a couple of numbers and rows and columns, you can simply do this command, which gives you a regular matrix without anything fancy to it. But if you want to have parentheses, you can also do it like this. So that, whenever you want to, you can add parentheses to it, and you can do it like that. One other thing is vectors and whatnot. So for that one, if you want to display a vector in a paper, you can simply use a command such as this, and it will render that vector as something like this. It would render it in italics, and it would put that little arrow over it, which looks quite nice. Of course, if you want to do a smaller vector, you can also do the \vec and put the letter in, and it'll get you something like that too, but smaller, if you really want something like that. Of course, given that these are also math-related equations and symbols and whatnot, you want to make sure that something like that is in dollar signs. Once again, there's loads of commands out there, and these are just a small sample of those. With some basic features of LaTeX that I've showed off, let's compare it to Microsoft Word. If you can't tell already, there's coding involved, quite a bit of coding involved. It's not as complex as making a game or writing a website. It's still coding. And there can be quite a bit of a learning curve to it, as while this coding may not be as hard as others, there's still quite a bit of a learning curve to it, as sometimes it can take quite a while to figure out what sort of lines of code you need, what commands you need, and whatnot. But of course, given that LaTeX is commonly used by many people in academic fields, there are loads of tutorials out there that can help you out with that. But one significant thing is that unlike Microsoft Word, LaTeX is quite accessible. As I mentioned, one of the ways I access LaTeX is through Overleaf, which is a cloud-based service that offers LaTeX for free. And it is one of the ways I can access it and do all the basic things that I need to do with LaTeX. But now for the pros and cons. Pros for Microsoft Word is that what you see is what you get. Despite the ease and convenience that might come with simple coding, sometimes the easiness of Microsoft Word might be appealing for some. As Microsoft Word, all you need to do is type out whatever paragraphs you need, and for some, that is just enough. It can be quite easy to learn because all you're doing with Microsoft Word is just typing out lines and lines of text and paragraphs and whatnot. And also, it is quite common in use because how many of you here use Microsoft Word for writing essays? Yep, quite a few of you. It's quite common in use. You use it every day in classes and business and whatever. LaTeX, for their pros, it is easier later on because with Microsoft Word, you might have to work with formatting it all the time. With LaTeX, you do a bit of coding at the beginning, and later on, the formatting is much easier. That way, all you have to focus on is simply writing your paper rather than how it might look like. And that can be quite convenient. As I've said before, it is free to use. Unlike Microsoft Word, which if you do not have a school or business account that has Microsoft Word easily accessible, it can cost you quite a lot. It can cost you almost hundreds a year to access alongside perhaps some other applications such as Excel or PowerPoint or whatever. Of course, unlike Microsoft Word, which is only accessible through Microsoft Word, LaTeX can be accessible through many different ways. So you can access it through online platforms like Overleaf or offline versions that you can download and work on your own without the use of the internet. But now for the cons. Microsoft Word, it can cost money quite a bit. And also with making equations, writing those equations can be quite difficult because sometimes you might need certain symbols, and that can involve having to look through their vast amount of symbols, scrolling through it, and that can take quite a bit of time and be quite inconvenient for some. And the formatting that can be involved with writing paper can be time consuming and take quite a while, which can be quite inconvenient. For LaTeX, the coding can also be a bit of a con because not everyone is good at coding. Not everyone might want to learn how to code. And it can be difficult to learn for some because they might not be good at coding and there might be quite difficulty in figuring out how that code might work. And the packages that might do a lot of things with your paper could also be considered a con. Given that there are hundreds, perhaps thousands of packages available, it can be quite a bit time consuming in figuring out which one does what. You might need to figure out which one do you need, which one do you want, which ones work together and which ones don't. That can be quite an inconvenience if you ever get to that point. But before I get to questions, I'd like to take a moment to perhaps look back on how it went in preparing for this presentation and also in my process of learning LaTeX. There is quite a lot to learn about LaTeX, and part of it goes beyond just learning how it works. Learning about LaTeX has allowed me to learn quite a bit more about how it works in the STEM field, because there's a lot more to it than learning about what sort of math formulas I need to do, what sort of math concepts I need to know, what sort of science and physics do I need to know? Because there's a whole other part of it too. And one of that parts is research, because depending on which sort of field you go into, there's going to be research that you need to do. And one of the parts of research that you need to also know is how does it work with publishing your research? How does it work with organizing it and publishing it? And LaTeX is one of those ways. Because one of the things you can also do with LaTeX that I likely should have mentioned before is that there's also an option to publish it, or some ways you can access LaTeX. And that makes it much easier to sort of get your paper out there and help yourself in the field. And besides that, one of the things that I've also learned is that there's quite a bit of preparation that goes into conferences. There's a lot of things you need to do in order to prepare for conferences such as this, whether it be rehearsing, organizing the slides, and learning a lot more. In the end, it has given me a lot of experience, and as something that I will be carrying on with me as I go further in life. With that out of the way, are there any questions?
So if you send a file to someone to look at, they need LaTeX to be able to read that file?
With sending a file to someone else, you can actually convert it into a PDF.
Okay.
And then from there, you can actually just send it to someone and they'll be able to read that just fine.
And I know when we're looking at the title PNG, and it was a typo, and you mentioned that that will create serious issues if you don't catch that. I thought you meant you'd have to redo the whole thing, but then you were talking about how with the percent, you can actually kind of like publish it or see it and then go back and immediately make changes. And so what are the issues? Is it just that you might have so many lines of code that it's going to be really difficult to find that typo?
I think whenever you see that sort of typo, whenever you see that image, I think whenever you see that, you can actually just click on that whenever you're in the application, whenever you're writing it, and it should take you to that line of code so I can just show you.
Nice.
Oh yeah, it is. It can actually show you where that line of code is, and then you can see where that sort of error might be.
Is there a lot of overlap between its coding and HTML? Or is it fairly different?
I'm not exactly familiar with HTML, but I'm quite sure that it's somewhat different from HTML.
It's slightly different because HTML is used to create websites,
Mm-hmm.
and that involves the regular coding like the Java or C++, like those formal coding languages, whereas this one is kind of like in between the real coding and the Microsoft Word. So it's a little different. And I think it's also
I've not done this, but I've read that the new chat GPT will actually code for people. I wonder if it knows LaTeX.
I
Here's where
wonder.
you go, I don't know.
I wonder about that too, but
yeah, we haven't used
But-
ChatGPT in math classes, so yeah.
But I wonder if it's, because I've only like tried to get familiar with it to spot it in submissions, but here it actually has robust coding capabilities right now. Because it doesn't have very robust writing skills right now.
Mhm.
It has technically proficient skills.
I'm sure ChatGPT would be maybe good at coding, but for writing LaTeX, I'm not too sure about
Yeah.
that.
I bet it can learn that. I mean, it's learning.
It's AI, so.
Like, we had a meeting and they said, we're safe because it doesn't quote yet. You can't quote sources. And a couple of days later, I had time, so I gave it a command and it quoted sources. So I sent an email to that person, said, no, 48 hours later, you're wrong. It learned it. So I mean, somebody has to show it to it, but it seems like if it's out there in the cloud, it probably can do it. And you did a really good job, because when we got to that one, I was like, oh, it needs percent signs. The dollar signs, it needs the dollar signs to space it.
And when you try to compile a document that has images and you realize that, oh, there's a typo on the name of the image, just like make a small change and then just like compile that, and then the image will show up.
I remember Shirley just whining about how hard it was to make the math stuff look right.
Yeah,
Documents,
yeah. Yeah, so like there are some differences between the math equations in Word and math equations in
It's
LaTeX.
clear and
Yeah,
it's easier to read and that's cool.
Thanks for asking.
You said you use this yourself?
Yes,
How long did it take you?
Yeah.
it took me maybe a week to sort of get the basics whenever I had some free time. And of course, I didn't have too much of a hard time thanks to my teacher sort of giving me the basics and of course, giving me some advice on some basic things to do and giving me a file of paper that he did himself and letting me play around with it and sort of format it to how I need it. That way I can sort of learn how the code works and how I can use it to sort of do stuff on my own.
Have people put tutorials on YouTube or places like that?
Oh, yes, I'm sure there's quite a lot of tutorials. I know I've watched a few.
yeah, if you want to create any LaTeX document from the blank, then it's really, like, it can be really tough because like even I haven't done that. Like, because I searched online to get some possible templates.
Oh.
And then I modify because like first you have to always start with like document class and then like article or whatever. And then you have to specify all the user packages.
Mhm.
And there are thousands of them,
That's what you
which I don't even know all of them. So it's better to just get some template and then just use it as a basement and then add some packages later on if you feel like you need to add something.
So with the different packages, like if somebody were just wanting to put together really professional looking newsletter or something, like just that type of technical writing, this actually, it's not just for math, right?
Right.
Oh, yes.
Right.
There's quite many applications outside of just writing math related applications, as you can use it for writing it in many other languages, maybe some that maybe don't exactly use sort of lettering that you might see in English or European languages.
It's something the learning management systems can identify, or would they have to, you said it can export as a PDF?
Export it as a PDF.
It's possible, but I don't know how
I know
it can.
It does HTML. but
Yeah, like this is different from HTML, so
it probably
we can try. Just put new elements coordinator. So
There's a lot of things you can do with LaTeX. Quite a few things.
yeah, you can even like write a like journal or magazine with this.
Mhm.
And like if you look at some like math journals, like they are all written in LaTeX, and I could tell. And once you insert like tables and then lots of pictures with captions, it looks really professional. Yeah.
At least I remember that when I've used it like however long ago.
There's also a very good way of adding in your sources too. You can actually,
Yeah, because in Word, like you have to like put a footer or like footer, I guess, yeah, and then like you have to like label it, and then like you have to see all like this come from my page, whatever from like this book. In LaTeX, you can create another document like bibliography or whatever, and then you can just quote that and then put that into the body of your main document, and then you'll like once you compile everything at the end of your paper, like you'll save a bibliography.
all right. Does anyone else have any other questions they'd like to ask? In that case, thank you all for coming to my presentation. And thank you to my teacher for offering me the opportunity to speak at this conference. Have a good day. Yeah.